What's up, YouTubers? Jose Quiñones, the CNS here with my new ARC Captain MIG 200 machine. As I introduced in my last video, I just acquired this machine because I was doing a project. My Hover 140 unfortunately died. It gave me 20 years of service, so I'm very happy with that. But I needed a new machine to finish the project. I found this online, and I have to say, so far I am quite impressed. So I want to do a quick introduction and review on what the machine is, what it has to offer, what I like and what I don't like about it. So like I said, this is the ARC Captain MIG 200. It is a multi-process machine, so it can do a MIG, ARC, TIG, and spool gun. I'm very interested in trying the spool gun at some point in time. I haven't acquired yet, but I have never done a spool gun before, so I'm actually intrigued on what that is. The machine will take either 120 or 220 volts AC. You don't need to do anything. There is no switch in here. You have to flicker or flip. It just knows that it has taken either 120 volts AC or 220 volts AC, and it probably is getting rectified inside to 180 volts DC or 350 volts DC, depending on the input. And then there is a microcontroller inside and an inverter, so everything is designed to probably withstand 600 volts. So it's a very simple circuit, which just takes whichever input and just goes with it, right? To do the same with a transformer machine, it's doable. I mean, it's not impossible, but I think it would be hard and maybe expensive, is my guess. I could be wrong, but my impression is that it wouldn't be cheap. So that's why you see all of the migration to the newer machines just being inverter, because it's just so much simpler. We also have to take into consideration that they did this with a microcontroller, I can assure you. Once you have a microcontroller, there is so much you can do. Of course, you're going to use the microcontroller to drive the inverter stage, the power stage, which is how you get whichever signal you can think of. So basically, we are synthesizing the output that goes into the weld, whereas on the transformer machine, you're just basically routing which transformer output is going into the weld, and it just limits you to basically an X number of settings, because it's based on the transformer. With the inverter machine, you can do pretty much whatever you want, and I'm going to show you what I mean by that. The other important aspect I wanted to mention was that I acquired this machine, but for years I've been looking at the Harbor Freight, what is it called, the Omni Pro 220, which is also a multi-process machine that can do the four things, the ARC, the MIG, the TIG, and the spool gun. That machine is usually $1,100, and with a coupon you might be able to get it for 900 and something. I forgot the math, but it depends on the coupon, it depends on the deal, and so on. But it's never gonna be as cheap as this one, and that's amazing, because Harbor Freight is already like the cheapest of the cheapest. Well, this one actually is like way cheaper than that. How much is it? Well, if you go to Amazon right now, and I'm gonna put an associate link below. Remember, I may make a commission if you click on that link. If you do, I appreciate it. But this machine is $500, except they have a limited time deal that takes the machine down to $400, $399 with 99, I believe, and there is a $50 coupon, so you can get it for $350 plus tax. In my case, it was like $380. But you must act quick, because this limited time deal only lasts from the beginning of the universe to the moment in which the sun consumes the planet. So it's limited time. But it's been there for a few months now, and I just checked today, it's still there. So I'm not sure what kind of a limit that is. Maybe it will go up as inflation keeps on going up in a few months. But for $380, unbeatable. All right, so I brought the second camera here to show you the controls up close. Right now I'm on MIG mode, but like I said, this is a multi-process machine, so you can switch by pressing the mode button. You can go to ARC, TIG, MIG spool gun, and back to MIG. Today I'm only going to talk about MIG because that's the only one I know how to use right now. But you know, there is a fancy booklet with all of the information that you need on the other modes. Once you're in MIG mode, of course, you have the voltage here. So you can see the voltage. And this knob changes the voltage. It can go from 11 volts to 22 volts in increments of 0.1 volts. So that's one of the things that I wanted to mention. When I was working with the Hobart, I had 4 voltages. That was it. But in here we can do whatever we want because there is a microcontroller in there synthesizing sine waves. So you can scale this in so many different ways. In the same fashion, we can control the speed. The speed is controlled from 2 inches per minute to 10 inches per minute. All right, so the speed is something that we did have plenty of different speeds with the Hobart 140 because there was a brushed DC motor with a little half H bridge that could control the speed. So that one is similar. The other thing that we can do that we cannot do with the transformer machines is select the control structure. So noticing here we have this diagram doesn't mean a whole lot to me, but basically this is what is called a trigger press for welding. So when you press the trigger, you're welding, and throughout the press of the trigger you are welding. But I can change this to another mode, which is basically press the trigger to start and then press the trigger to stop. So you gotta do 2 presses at the bottom. I personally do not see myself doing this. I have to imagine you would do that if you were going to be welding for a very long time and you may get tired of pressing the trigger. I guess if you have arthritis, that may be something, but you know, I have arthritis and I don't plan on using this mode, to be honest. The last mode is the spot welding. So spot welding allows you to just press the trigger once and it will weld for an X amount of seconds, which are programmable. So how do you select the amount of time? Is by pressing the plus button, and now you go to seconds. You can change from 0.1 second to 5 seconds. Okay, so that's how you select for how long will the spot weld last. I'm gonna put it on 0.5, press play again. That's memory. Here we go. No, that's bolts. Where are bolts? The other mode that the machine has, which I'm gonna be honest with you, I don't think I'll ever use it, but it's called synergy mode. So in synergy mode, you're basically telling the machine, here, you figure everything out for me, and then kind of select the parameters based on what you're gonna do. So you go there by synergy, and now there are like metal thicknesses, or actually the thickness of the wire, and you can select which gas you're gonna be using. So let me see, forget which, no, that's not it. See this is for the thickness of the wire. This is like a little circle with 2 arrows. I'm not certain why that spells wire, but you select the wire here from 0.35 or 0.4. And if I recall, you could also select what kind of welding you're going to be doing. If it's ferrous with CO2, if it's ferrous with a mix, so I guess CO2 and argon. If you're going to be doing flux core, or if you're going to do, I believe this is for stainless steel, and I'm not sure which one is this. But just select that, and then the machine kind of adapts to what it needs to be. Once you're in any of these modes, because you see here it's in synergy mode, when you select the current, it selects the voltage for you as well. So I guess this may come in handy if you don't want to be worrying about what you need to do, but then you're kind of bound by what the machine selects. To go back, just press Synergy again, and now you are in you selecting voltage and IPM. So notice that if you are not in Synergy mode, you cannot select the gas, or you're basically on your own on what you're going to do. You can also not select the thickness, depending on which mode you are in here. I mean, depending on which gas or wire process, you have different options for thickness. So I guess it knows what are all of the available options depending on this one. So not all of the options are available for all of the different processes. But you know, again, this is probably too advanced for this video. Just be aware that these options are available and that the machine has all of that variability. I always forget, there is a last knob in here called the inductance, which basically just selects, I'm not sure exactly what they call it, inductance, but in essence it's the arc strength. And you know, you're not going to see any number in the panel, but basically it goes from 0 to 100%. I usually leave it here where it says standard. What the inductance does, according to what I read online, and remember, this is completely new to me because the transformer machine didn't have anything of this sort. Basically, what you're controlling here is how much spatter you're going to generate, and I guess it has to do with the frequency of the basically the switching frequency of the inverter. And it makes sense to me that this is something only inverter machines could have, because the transformer based machines, they would be bound by the frequency from the line power, which in my case would be 60 hertz. So that's basically the switching frequency of the weld, and there is nothing else changing the frequency here as far as I can tell. But on the inverter, you can have any frequency that you can think of, because I mean, not any frequency that you can think of, but pretty much you can synthesize a sound wave of pretty much any frequency, and that's probably what they're doing as you change this here, and that basically changes the quality of the weld. So basically what I have seen out there is that if you go to 0, you're going to get a lot of spatter. If you go to 100, you're going to get way less spatter. I'm not sure exactly why center is better, but again, from what I've seen online, they're all good. They will all give you good results, at least on the experiments that I saw. I'm not knowledgeable enough to tell you on which case you would need to use low inductance or high inductance, or low switching frequency or high switching frequency. That might be something somebody with much more knowledge than me can help us. So if you know the answer to that, please put it in the comments. But you know, I'll just probably just working here unless I eventually learn of something that is of incredible importance on why I should have used it on somewhere else. The important thing is that you have the ability to change that parameter, which in a transformer machine, there is nothing like that. So now this may seem like too many knobs, but to be honest, it's not that many. It's not like we're controlling here the space shuttle. So it's not that bad. I mean, it didn't even take me long to figure out how to get really good welds, and my project is looking pretty good. So don't get intimidated by the sheer number of parameters here. You don't need to use them all. Like for example, I don't even see myself going into the synergy mode unless I learn something that makes me decide that I have to do it. So far, MIG, voltage, speed, and then just leave the inductance here. That's all I need. And of course, something you will want to do is take a piece of, some piece of steel that you're not going to do much with it, and run a bunch of experiments. As you can see here, I have different, I basically play with the IPM. So I set my voltage to 18 volts, and then I went to town with the different IPMs just to get an idea of which one I like. Of course, you can see that the low IPM didn't look as good as increasing the IPM. So you can play with this stuff, and then you can change the voltage and repeat the same experiments and get an idea of which one is better. So you can see that if you lower here, I have an experiment with 10 IPM, and I just lower the voltage from 11 to 18, and of course the low voltage doesn't work. Maybe you can add inductance to it, and maybe you can get different results depending on, different good results depending on how you play with it. But these are games that you can do on your own to determine which welding parameters you want. Obviously, the higher the voltage, the better. The lower the voltage, the worse. Well, there you go, YouTubers. This is my quick review on the ARC Captain MIG 200 multi-process welder, which you can acquire at Amazon and maybe some other places. From Amazon, it's only $380 or so. It's a really cool piece of equipment. I plan on trying the spool gun at some point in time, just because I've never done aluminum welding, and I will be looking forward to doing that. Really cool little piece of equipment. I am super happy with it. I did mention at the beginning of the video I was going to talk about the stuff that I like and the stuff that I didn't like, and I thought about making a joke and just closing the video by saying, okay, now let's talk about the stuff that I didn't like, and immediately just switching off. But there is one thing that has been mesmerizingly annoying about this piece of equipment, and I'm not certain where the heck this stuff happens, but it seems like whenever I buy an import piece of equipment, and this happens a lot even when I go in a Harbor Freight tool, it smells like I am in a tire store and there is some kind of degassing going on, and there's like this rubbery smell that is very penetrating. This machine has, it's like probably these pieces of plastic and all of this rubber is just degassing that rubbery smell. So it creates, like, surrounding the machine, it creates this atmosphere of tire smell or rubber smell. I don't know how to describe it, but I can come into the shop and I'm on the other side of the shop and everything is good. And as soon as I approach the machine, it's like, whoa, I just entered this parallel universe where it smells like rubber. I don't understand why that happens. It must be that the materials selected have this property, but it happens a lot when I go into import, places where I have a bunch of import product, which is amazing how prevalent that reality is. But that's the only negative aspect that I can mention today. Everything else is pretty good. I have an impression that this thing is not gonna last a lot, because let's face it, even the Harbor Freight tool welder is $1,100, and that's cheap compared to if you want to buy a Hobart or a Miller or any of the good ones. So $1,100 is already cheap, and this one is like a third of that. So I am thinking that one day I'm gonna weld something and it's not gonna weld, but so far so good. I'm surprised. So I want to thank you for staying with me all this long. If you like this video, feel free to press the like button. If you like the content that I have in this channel, feel free to subscribe. If you have ideas on or any other things that you want to share with the community on this kind of equipment, and what are things that they should be mindful of, feel free to post it in the comments. But I definitely appreciate you staying this long with me, and I want to thank you for tuning into my YouTube channel. I'm gonna see you on the next one. So I just brought my second camera with a hangman stand to show up close what this looks like. So here, this guy, we can see the MIG selection here. That's basically the mode. Like I said, this is a multi-process, so we can do MIG. Whoa!